Good morning, ladies and gentlemen. I'm glad to give a short presentation about the development of Industry 4.0 and made in China, and we will also pay much attention to the education about the talent for Industry 4.0. So. Now we are just living in a new age, which we can call it as the digital transformation. And in the past 30 years, the development of information and communication technology bring us a big change. In the following, I would like to give a short summary to some key technology. The first one is embedded systems, which is the combination of hardware and software. It's enable ubiquitous computing, which is the fundamental for smart equipment or smart device. The second one is mobile communication, which includes also a wireless network and cellular network. It's belong to access and interconnection technology. The third one is about website, or we can also call them internet and technology. This is about all the technology and applications about internet. Today, internet there's not not only internet of data, but also internet of things and internet of service, which can be taken as a footstone of industry of smart factory. The rest of two kinds of technology which we heard and discuss every day. That is cloud computing and big data. And the last one I want to mention is this artificial intelligence. We are just standing in the threshold of AI age. One of the famous news is this AlphaGo just beat the woman, which maybe we thinking about this big catastrophe to us to our people. Okay. With the development of ICT technology, the global manufacturing sector are just facing a big change. So intelligent manufacturing become a main direction of each country. For example, in United States, from 2009 until now, a series of production plans for advanced manufacturing has been launched. In Europe, there are some joint plan for example, this virtual factory, and also part of plan in Horizontal 2020 is also about intelligent manufacturing. Of course, in different countries, there's also individual development plan. The famous one is the Industry 4.0 in Germany. Even in some emerging country or developing country, and some industry and developing plan has also made. then we turn to China. China is facing lots of challenges. For example, what we call as directional comparison from developed countries and other developing countries. To deal with this challenge, China launched a lot of plans, and the key parts of this plan are always focused on intelligent manufacturing. So, because since the former speaker has already talked a lot of about Industry 4.0, so here I just want mention something what we think interesting to us. One thing is the Industry 4.0 platform in Germany. It's very relevant, of course, because the member of this platform come from government, companies, research institutes, and so on, and they give different public service and for the development of Industry 4.0. What we think this is a very good of Deutsch Vorbild for China. Another thing what we think is especially good in German Industry 4.0 is that there is a clear roadmap. This roadmap is not only used for German, but this is also a good suggestion for our research work. And there is a reference architecture, an application map, and evaluation systems. What I still mentioned is that from the very beginning of the development of Industry 4.0, and the talent development is put at a very high level. Okay, then we will talk something about our China. The hottest topic now in China, of course, is this Made in China 2025, which is the three-step development plan, which will change China from a big manufacturing country to a world power. The key idea behind Made in China is the intelligent manufacturing. And in China, from central government to local government, there are different and there are different programs. In different parts of China, there are some different strategy. For example, in East China, Central China, and West China, the key point is a little different. Okay. Then the last part is what we will pay much more attention. That is for the talent and cultivation. We classification the change of the position in four classes. One class is some traditional low-skilled lab, which we will think that in the future there will vanish. And the second class is some position, for example, this automotive assembly line worker. And even in the future, this position will still exist, but the requirements of a skill will be changed, because in the future the people, or we can say the worker in this in those automatic assembly line will not just operate it, but will design it and reconfigure it. And the second class is some people, for example, software developer and data analysis and for human machine interface. Those people will be big required. And the last one is which we're taking as the top one. This is someone did some work for system integration or some system level work. Until now, there is still a lack of a systematic way to training those people. Generally speaking, there are the old and low scale lab, the position will decrease, but the high skills engineering for innovation in the future will be greatly required. And consider this situation. We make some research about cultivation model. This is the combination from different reference model. For example, the left one is the famous Rami, and the middle is from IIoT in America, and the third one is just the reference model in China. In this case, we have a group model, and there are three axes. One axis is the major, the other axis the axis is the application fields, and then this axis is about the capability. And the former until now a student or people only with a single major from a single application field with certain level. So this is just a point in this group. But in the future, normally the people need know the technology from at least the two or three major. In this case, we divided the talent in age of intelligent factory into three classes. For a button is the professional and talent. Those people has some deep technology with one or two major. These people normally is in the first line in your company, and then for the second level is some interdisciplinary talents. They have a good knowledge to different major and to different application fields. So which means they can do some simple design work for a smart factory. The top level talent, which we call systematic talent. Those people we can also call them as assistant architecture design or assistant integration design. In order to get these goals, we find that there are some related major. For example, those 5 major is the basic for intelligent manufacturing systems. For example, electricity, automation, and computing and industrial engine. And then the key technology, for example, AI, big data, and cloud computing, virtual reality, and augmented reality physics systems is the basic knowledge for those people. In our university, we make detailed education plan for talent and cultivation. This is with 5 stages. The basic stage is is some public course. This is for example, advanced maths, physics, and so on. And after nearly 1 year, this public basic course, then is some basic professional basic professional course. This is a bit different as the traditional college major, because here the course is come from different major. For example, mechanical design, control engineering, product planning, and so on. Then in the third years, the student has a major course. This is according to different direction. There are different groups. For example, something is about industrial software. Something is about the control of the intelligent manufacturing, and then there's also a major selective course. This is just give the students have some knowledge about some quite new things in intelligent manufacturing. Most important things in this system is we put a very big attention to practical teaching. We have a so-called project-based learning, which means the students should not only to hear the course, but they also must do some practical projects, just like in a company. This is a table of these sort of things, and with 4 years, there's a totally 175.5 projects. This is in Northeast universities already very much credits, because our presidents in the university always ask us to reduce the credits. Otherwise, the students will bear too much things. But sorry, for quite new technology, the students must learn so much things. And just as I mentioned, we pay much more attention to this practical parts. More than 20 course is about this subject. So this is some principle in this systems. First things is this of course that this is multidisciplinary, and another is practical based. It's practical based, and the third one is with this with what we call with this project based learning. Of course, international cooperation is always like a key part to this systems. Okay, this is all for today. Thank you for your attention.